This is the first video in a series explaining the method of partial fractions to integrate rational functions. So what we'll do in this first video is we'll define what a rational function is, and we'll just go through the integrals that we can already integrate with what we've known, and then in the future videos we'll start looking at how partial fraction helps us integrate more rational functions. Alright, so first of all, a rational function it's a fraction where both the top and the bottom, the numerator and the denominator, are both polynomials. So it's a fraction p of x over q of x, where both p of x and q of x are polynomial. Alright, so for example, if I ask you to give me a rational function, you just have to think of two polynomials, but one as the numerator and one as the denominator. So I'll take x squared plus 5x divided by x cubed minus 6x plus 5. Anything would work. This is a rational function. Our goal for this section is to learn how to integrate all of them. So to start, let's look at rational functions that we can already integrate. So I'm going to start Alright, so first let's say I want to integrate 4 over, let me make sure I take the same one you guys have, 4 over x plus 5. This is a pretty simple rational function. It has a constant on top, a linear term underneath. How would you integrate this? What I would do is I would use a substitution. I would take all of this denominator, I would call it u. Since I have a 1 in front of x, du will just be dx. So this integral will turn into 4 over u du. That gives us 4 ln of absolute value of u plus c, and so I would get 4 ln of absolute value of x plus 5. Don't forget your plus c. Alright, so for functions that are this simple, we don't need any extra help. We don't need a new technique. A very basic substitution would actually give us the answer. Alright, second, If I have this integral here, still a constant above, now the denominator is x squared plus 9. It's a quadratic. I might be tempted by a substitution like this, but in this case it wouldn't work. If I take u to be x squared plus 9, du would need to have an x dx, and I don't have an x on top, so that wouldn't work. But for an integral like this, you have a couple of options. You can use inverse trig substitution, which we just learned, or you could just use one of the basic integrals. Remember, we have this. We learned and proved this formula here. We get 1 over 8 arctan of x over a plus c. We'll use this for our integral here. The 4 will just come out. I'm going to use a squared is 9, so a will be 3. Always take the positive one. So 4 times 1 on 3 arctan of x on 3 plus c. And so again, for integrals like this, we don't need a new technique. We can already compute it. I have one more example to show you. What if I have x? Actually, let's do it here. Yeah. All right, what about this integral? It looks a lot like the preceding one, but instead of having a constant on top, I'm going to have x. And it turns out that this little change will mean a completely different solution. Here, that x will let me take a substitution. I'm going to take this entire denominator to be my new variable. The du will look a lot like x dx. So I will take u to be x squared plus 4. Du will be 2x dx. I have x dx, so the x will cancel. Let me solve for dx in this. I replace the dx by 1 over 2x du. This cancels with this. I end up with a 1/2. And then my whole denominator is u. That's how I picked u. I get this. That's simple enough to be a basic integral. And then I plug u back in. And here's your answer. So we already know how to integrate basic rational functions. We have three different types here. Those three types we know how to integrate. What partial fractions will do is it will take any rational function and turn it into a bunch of these types. So partial fraction will break up rational functions into these simple types that are called partial fractions, so into building blocks like we'll have often a over x minus a. So that's like the example, the first one I did. We'll have bx plus c over a quadratic. So x squared plus bx plus c. And other simple building blocks, there are just a few other ones that we can already compute. In the next video, we'll start learning how the method of partial fraction breaks up a rational function into these building blocks and how to find exactly what all of these constants are.